Welcome to ACM Shorts. Today's topic is fly ash and slag cement, also known as pozzolans. So why do we use pozzolans? Turns out there are three very good reasons. Cost. Use them as to partially replace cement and save money. 2. The environment. Recycle byproducts from other industries. 3. Concrete performance. Improve long-term strength and durability and appearance. Let's start with slag cement, which some of you will remember used to be called GGBFS, or ground granulated blast furnace slag. The blast furnace refers to the fact that slag is a byproduct of steel production, so it's found where steel is fabricated. As steel production has declined, the availability of slag cement has decreased and the price has risen, so it's no longer as economically attractive to use it as it was in the past. How does slag cement affect concrete performance? On a microscopic level, slag cement is angular in shape, so it does not help flowability. It's also very light in color, almost white, so it's naturally good for lighter and brighter colors, which can reduce pigment loading. And for some producers, this is the primary reason to use slag. Most concrete product producers use fly ash, either Class C or Class F. Like slag cement, fly ash is a byproduct, but of the coal industry. There is a lot of fly ash produced during coal production, and recycling it into concrete has environmental benefits in reducing waste. As with steel, coal production has declined and the supply of fly ash has gone down, while the price has gone up, but it's still an attractive alternative to cement. Fly ash has a similar particle size to cement, but it has a spherical shape, like mini ball bearings, which helps the mix to flow and fill the molds properly. We mentioned Class C and Class F fly ash. Class C ash is typically tan in color and is found mostly in the western part of the US. It has higher reactivity and can react faster than Class F. Class F is more gray in color and is found in the eastern half of the United States. It's not as reactive and therefore has lower strength gain than Class C. Let's talk about the pozzolanic reaction, another great reason to use pozzolans. As you know, when Portland cement mixes with water, a chemical reaction called hydration occurs. Cement hydration hardens the cement and glues the concrete ingredients together. The products of hydration are CSH gel, which is the good glue, and calcium hydroxide, which is a byproduct. And unfortunately, what this also means is that calcium hydroxide is always present in Portland cement-based products. As we can see, the hydraulic reaction is not very efficient. Around 25% of the hydrated product is calcium hydroxide. This is not what we want because calcium hydroxide raises the potential for efflorescence. So how can we limit the production of calcium hydroxide? Interestingly, pozzolans have no cementitious properties by themselves when mixed with water. For example, if we mix water and fly ash, this will only result in a wet slurry. It turns out that fly ash and slag cement both act as activators. When we combine them with calcium hydroxide and water, we can initiate a reaction between the three components that produces CSH gel. In this way, we can significantly reduce the amount of calcium hydroxide, get more good CSH gel, and reduce the potential for efflorescence. Sounds like a winner. Another good reason to use pozzolans is that they also increase long-term concrete strength and durability. We should also note that there is a trade-off between the amount of pozzolan and strength development. The more cement we replace, the slower the initial strength gain will be. This is because the pozzolanic reaction is a slow reaction that needs time and sometimes additional heat to make it happen. Thanks for joining us for this ACM short. We'll see you next time.